Hello and welcome to Algebra I Lesson 41. In this video, we're going to learn about special factoring rules. So back when we learned how to multiply polynomials, we did a lesson on special products. And that lesson was meant to greatly increase your speed when you had to find certain polynomial products that occurred very often. So for example, one of the ones we looked at x plus y, that quantity squared. And you know it's the first term squared plus 2 times the first term times the second term, so 2xy, and then plus the final term squared, so y squared. So without using FOIL, I'm able to multiply that instantly. And you can look at an example that's not generic. You could do something like, let's say x plus 5, that quantity squared. So that would be x squared plus 2 times x times 5, so that's 10x, and then plus that last term, which is 5 squared, that's 25. So I'm able to use that formula to very quickly get the answer. Now, we saw this on a few different things. We also looked at kind of this with a minus sign, so x minus y, that quantity squared. And the only thing that changed here was the sign. So it was x squared minus 2xy plus y squared. So as another example with just numbers, let's say we made this a little bit more complex. And we said this is 4x minus 5, that quantity squared. Well, the first term here, the 4 and the x, would be squared. So 4 and the x, that's all squared. Then minus the first term times the second term times 2. So 2 times 4 is 8. 8 times 5 is 40. Then times x, so minus 40x. And then we have our final term, which is 5. That would be squared, so plus 25. So to simplify this, 4 squared is 16, and x squared is just x squared. So this would be 16x squared minus 40x plus 25. So a much quicker way to do that versus going, okay, well, this is 4x minus 5 times 4x minus 5. You know, first times first is 16x squared, and outer is minus 20x, and inner is minus 20x, and last is plus 25. You know, combine like terms here and get this over here. So let's kind of reverse this process. We already know how to do the multiplication part. We've already gone through that lesson. So now what we're going to do is learn how to take something in this format and put it in this format. We're going to factor it. So we're going to start out by factoring the difference of two squares. So remember, when we went to our lesson on special products, we had the quantity x plus y times the quantity x minus y. So it's the same thing here and here, and the same thing here and here. So in other words, the first position of each is x, the second position of each is y. What is different is going to be your signs, right? The plus and the minus. So this turns out to be the x, what's in the first position of each squared, minus the y, what's in the second position of each squared. Remember, the middle two terms are going to drop out, right? Because the difference of the signs makes them cancel. So you get x squared minus y squared. So in this lesson, we're going to go from this format to this format. So the first question you would ask is, how can we identify a binomial as the difference of two squares? Well, the first thing is that both terms must be squares. And what do I mean when I say both terms must be squares? Well, when we square something, we multiply it by itself. So in other words, if I have 2 squared, I know that's 2 times 2, or 4. We know that at this point. But if I looked at the number 4, I've got to be able to identify that that was created or can be created from 2 times 2. And I know there's other ways to get 4. It could be 1 times 4. It could be, negative 2 times negative 2, all these different variations. But you're looking for numbers or variables that can be created from some number or some variable multiplied by itself. So for example, if I have the number 9, that's 3 times 3. And again, it could be other things. It could be 9 times 1. It could be -3 times -3. But, let's keep things positive and keep everything very simple. If I had a variable like x squared, well, this is x times x. Or I could make this much more complicated. If I have a variable like, let's say, x to the 10th power. Well, this could be x to the 5th power. That's squared, right? Because if we keep the base the same and we multiply exponents, this would be x to the power of 5 times 2, which is 10. So x to the 10th power is really x to the 5th power squared. Or if I wanted to do something like a number and a variable, let's say I did something like 25y to the 8th power. Well, 25 I know is 5 times 5. And y to the 8th power I could write as y to the 4th power. So if I squared this whole thing here, this would be 5 times 5 or 25. And y to the 4th power squared, remember, keep y the same, multiply the exponents. 4 times 2 is 8. So 5y to the 4th power squared would give me 25y to the 8th power. So this is what you're looking for when you're looking for the difference of two squares. So both terms must be squares. Now, the other thing is that the second term is going to be negative. So your second term is negative. Now, I say that, and let me put a little notation next to it. This can be changed around. Because remember, if we have something with addition and subtraction, we can flip things around into a different order. So your teacher might try to trip you up. Let's say you saw something like x squared minus y squared. You know this is the difference of two squares. We already seen that this can factor into x plus y times x minus y. So another way you might see this presented, your teacher might try to trip you up, and she might say, okay, well, you have negative y squared plus x squared. Well, it's not that the second term is negative now, but remember, I could reorder these. I could change this into this, and it would still factor the same way. So just pay close attention to that. You want one of the terms to be positive and one of the terms to be negative. So those are the two conditions. All right, so let's start out with an easy one. So we have a squared minus b squared. So we have a squared term here and a squared term here. And then we have a positive and we have a negative. So that's exactly what we're looking for. Now, we just follow the format. We take, remember, when we had x squared minus y squared, this was x plus y times x minus y. So you can kind of think about it as, okay, what's being squared is going to go in the first position of each. So what's being squared here is the a, so that's going to go in the first position of each. And then notice your signs. You have different signs, plus and minus. So you'll have plus and minus. And then look at what's squared here. You have y. So that's going to go in your second position of each. Same thing here. This b here is squared, so that's going to go here and here. So a squared minus b squared is going to factor into a plus b, that quantity, times a minus b. And so we already seen this so many times with our special products formulas. We already know that this goes back to this, right? So we don't even need to check it. So let's take a look at one that's a little bit harder. So we have n squared minus 16. So we're looking for two squares here. So we know this is a square. And then what about 16? Well, yeah, this is 4 times 4. So I'm going to rewrite this for my convenience as n squared minus 4 squared. And that makes it easier for me to follow that formula. Again, I'm going to write this a few times. X squared minus y squared is equal to x plus y times x minus y. So then this is just equal to what? It's equal to n plus 4 times n minus 4, right? Following that format. Whatever squared here in the first position goes in the first position here and here. Then whatever squared here in the second position goes in the second position here and here. And just remember to alternate your signs. It's just that easy. And again, we know from our special products formula that n plus 4, that quantity, times n minus 4, that quantity, would give us n squared minus 16. All right, what about x squared minus 25? We know this is a square, and then 25, we know that's 5 times 5. So again, you can rewrite this, x squared minus 5 squared. And again, just follow your formula. If you want, I'll just rewrite it every time. So x squared minus y squared is equal to what? X plus y times x minus y. So then this is equal to what? It's x plus 5 times x minus 5, right? Whatever squared in the first position goes here and here in the first positions of each. Whatever squared in the second position goes here and here in the second position of each. And then again, you know how to check this. You have your special products formulas. We know that the quantity x plus 5 times the quantity x minus 5 would give us x squared minus 25. All right, let's take it up a notch. We'll look at one that's a little bit more complicated. So we have 9b squared minus 16. So then this one right here, we know 9 is 3 times 3. Obviously, b squared is a square. And then 16, we know that's 4 times 4. So again, to follow that kind of formula, I can write this as 3b, that quantity squared, minus 4 squared. And then I can write this, remember, whatever's in the first position that's squared is going to go on the first position of each. And then whatever's in the second position that's squared, that's going to go on the second position of each. So this becomes the quantity 3b plus 4 times the quantity 3b minus 4. And again, if you want to check this, you know your formula already. It'd just be first times first. 3b times 3b is 9b squared. And then you know that the middle terms would drop out, so the outer and the inner would go away. You just need to think about the last. You have plus 4 times negative 4. That's going to be negative 16. So you would get 9b squared minus 16 back. All right, let's take a look at another one. So we have 125x minus 80x cubed. Now, a lot of you will see this cubed here and say, well, this isn't the difference of two squares. I want you to remember something. Whenever you factor, you want to think about what's common to everything before you even start. So I would think about, okay, both terms here have an x, right? At least one. This one's obviously got 3, x times x times x, but this one has 1, and this one has at least 1. Then both of these guys are divisible by 5. This is 16 times 5, and this is 25 times 5. Now when you see that, you can see that 25 is 5 times 5, and 16 is 4 times 4. So this looks like the perfect kind of trap question you get on a test. What they want you to do is they want you to factor out the GCF first. So the GCF is 5x. So if I pulled that out, what I'd have left, 125x divided by 5x is going to be 25, and then minus, then 80x cubed divided by 5x would give me 16x squared. Now, this isn't in the format that we're used to. We're used to a variable here or something like that, but we still have something that's squared minus something else that's squared, right? So that's exactly what we're looking for. Let me erase all this. And again, we're putting our 5x out in front, and then we'll set up 2 parentheses here. And so 25 is what? It's 5 times 5. So we would have 5 here and 5 here. And then we have a plus and a minus. 16x squared we can think of as 4x times 4x. So I'll put 4x here and 4x here. And if you go through and you do FOIL, 5 times 5 is 25. The outer, which is negative 20x, and the inner, positive 20x, would cancel. And then the final, 4x times negative 4x, is negative 16x squared. So that checks out. And if we multiplied this by 5x, we would get back to 125x minus 80x cubed. So now let's take a look at something else that's very common. We're going to look at some perfect square trinomials. So perfect square trinomials. So in other words, a trinomial, again, is a polynomial with 3 terms, and it factors into a binomial that's squared. So in other words, this guy right here, we already know the formula for this. This is x squared plus 2xy plus y squared. So if I factored it into this, really I could write this as the quantity x plus y squared, right? These two would be the same. So if we see something like this in this format, and we notice that we have the first guy squared and the last guy squared, and then the middle is 2 times both of the terms in the squared binomial, so 2 times x times y, well, we have a perfect square trinomial, and we can factor it using this formula. So another occurrence of this, we have x minus y times x minus y. And so again, this is x minus y, that quantity squared. We already know this turns into x squared. We have a minus sign here, then 2xy, then we have a plus, and then y squared. So same thing, just when you have a negative there, that sign right there is going to be negative. If I have the x plus y, that quantity squared, all the signs are positive. But everything else, all the terms are the same. All right, so let's take a look at the first example. So we have x squared plus 6x plus 9. So again, the first thing I'm going to look at is to see if this is a square. So yeah, this is x squared, and then is this a square? Well, this is 3 squared. Now the next thing I'm going to look at is the middle term. If I multiplied 3, which is what's squared here, times x, which is what's squared here, so 3 times x is 3x, times 2, do I get the middle product? I do. 2 times 3 is 6, 6 times x is 6x. So then I can factor this guy as this, what's squared, which is x, plus this, which squared, which is 3, that whole quantity squared. Right? This turns into x plus 3, that quantity, times x plus 3. All right, let's take a look at 25p squared minus 30p plus 9. Now pay attention here because we have that minus sign. So we know that if this ends up being factorable, there's going to be a minus sign in there. Right? You'll have something minus something else, and then it'll be squared. So let's check to see if we have squares here. So we have 25p squared. So that's 5p, that amount squared. And then we have 9. That's 3 squared. And then what about our middle product? Is it 2 times 5p times 3? 2 times 3 is 6. 6 times 5 is 30. 30 times p is 30p. So yes, that all works out. So we would write this. We take what's being squared in the first term. So that's 5p. That goes in the first position. And then minus, we take what's squared in the last position, that 3, and we write that. So you get the quantity 5p minus 3, that's squared. All right, let's take a look at another one. So we have 49x squared minus 84x plus 36. So this guy right here, you think about 49, that's 7 times 7. And then x squared is x squared. So we'll put 7x, that guy squared. And then for 36, we think about that as 6 squared. Right, 6 times 6. So is the middle term 2 times the product of 6 times 7x? 2 times 6 is 12. 12 times 7 is in fact 84, and the x would come along for the ride, so that would give you 84x. Now, there's a minus sign here, so when you set this up, it's going to be this guy here, 7x. There's a minus, and then this guy right here, 6. So this amount, this quantity, squared. All right, let's take a look at another one. So we have 72x cubed plus 120x squared plus 50x. So the first thing I notice right away is that everything has an x, right? That's common to everything. Now everything is also divisible by 2. So I can pull out a 2x before I even begin. And what that's going to give me is 36x squared plus 60x plus 25. And I notice right away that 36 is what? It's 6 times 6. So this would be 6x, that amount squared. 25 I know is 5 squared. And then for your middle term, 2 times 5 is 10. 10 times 6 is 60. X comes along for the ride, so I would get 60x. Now, all I need to do, again, make sure you have that 2x out in front. I would put 6x in the first position. I have 2 plus signs here, so this is going to be plus. And then I would put 5 in the second position, and then this is squared. So this is going to factor into 2x times a quantity, 6x plus 5 squared. All right, so lastly, we're going to look at factoring the difference or also the sum of cubes. Now, this is one that's going to be confusing for you at first because when we looked at our special products lesson, we saw something that was similar, but it's not the same. And I'm going to show you that in a minute. Let me go through and just kind of use the distributive property on this and show you what you get. X times x squared is x cubed. X times xy is plus x squared y. And then x times y squared is plus xy squared. Negative y times x squared is minus x squared y. Negative y times xy is negative xy squared. And then lastly, negative y times y squared is minus y cubed. Now what's going to happen is x squared y minus x squared y. Those are going to cancel. Plus xy squared minus xy squared. Those are going to cancel. And what I'm left with is x cubed minus y cubed. So this is one that's going to dramatically speed up your time to do homework or take a test. So you have to memorize it. It's something you just have to practice, write down a flashcard, just kind of go through. Now, here's what I'm going to tell you. This is not the same as when we looked at the quantity x minus y cubed. Remember, I can't just distribute my exponents and say this is equal to x cubed minus y cubed. No, wrong. Remember that, okay? These are not the same. I taught you this formula already, and it's really easy to remember. If I have a minus here, I have x cubed, I have a minus here, and then remember I have a space, a plus, a space, a minus, and then a y cubed. So what goes in these two blanks here? This is a 3, and this is a 3. Remember that from the exponent. And then each term goes in there. Each one is squared only once. So in other words, I'll do x squared y here, and I'll do x y squared here. So this is what this is equal to, and this is what this is equal to. They are not the same. So please understand that, because a lot of students will see something like this, and they'll try to factor it into this. It's not the same. Okay, so please understand that. This formula was something we talked about when we looked at special products. So let me erase this real quick, and I want to show you the sum of cubes. So this is the difference of cubes. This, again, is the difference of cubes. And we're going to look at, this one is the sum of cubes. So x times x squared is x cubed. X times minus xy is minus x squared y. X times y squared is plus xy squared. Y times x squared is plus x squared y. Y times negative xy is minus xy squared. Y times y squared is plus y cubed. So everything's going to cancel except for the x cubed and the y cubed. So let's go ahead and do that. So negative x squared y, positive x squared y, those are going to cancel. Xy squared minus xy squared, those are going to cancel. So what I'm left with is x cubed plus y cubed. So this one, because there's an addition sign in it, is called the sum of cubes. All right, when I raise something to the third power, it's called a cube. Right, I cube it. So that's why it's called the sum of cubes. You have two items there, or two terms that are both cubed. All right, so the main difference here is going to be the sign. This is just something you have to memorize. When I have a minus in the first guy, and then I have all pluses in the second guy. Okay, so you kind of have to remember that the first one is the same, the second one is going to be different, and then the last one is always going to be positive no matter what. So same, different. That's how I remember it. If you look at this one, same, different. Last one's always positive. Okay, same, different. That's how I remember it. Again, put that on a flashcard if you want to. Or maybe there's some other trick you got out there to remember it. It doesn't matter at the end of the day if it's math, whatever you can use to memorize it. As long as it works, it works. All right, so let's take a look at m cubed minus 1. So m cubed is obviously m times m times m. What about 1? Remember, 1 times anything is just itself. So if I have 1 times 1, that's 1. If I have 1 times 1 times 1, that's still 1. So this is 1 cubed. So this follows the format of something cubed minus something cubed. And so we can write it using that formula that we just learned. And let me rewrite that one. So if I have something that's x cubed minus y cubed, this will factor into, this is how we're going to memorize it. We have x and we have y. What's the first sign? Remember, first sign is the same. Then we have x squared and we have y squared in the end. This is always plus. What's the sign here? Remember, same, different. So this is minus, this will be plus, and then you have xy. So following this formula here, all I need to do is think about, okay, this is what's cubed and this is what's cubed. So in the first thing that's cubed, it's going to go where? It's got a position here. It's got a position here that's squared. and then it's got a position here, and then that's it. We're going to subtract this guy, then we're going to add 1 times this guy, which is just itself, and then we're going to add that guy squared, which is just 1. So we get the quantity m minus 1 times the quantity m squared plus m plus 1. And I know these are a lot more challenging, especially when you see them at first. It's like, hey, how am I going to remember that? If you do enough practice with this, I suggest doing a lot of practice, because by the time you get to Algebra 2, you're going to need this formula to get through a lot of the tests that you're going to take, especially like the SAT and the ACT, all these standardized tests that you're going to take where time matters, right? So if you know the formulas, you can go through and crank these things out very quickly and be assured that you have the right answer. All right, so let's look at x cubed plus 125. So what's our formula? Again, x cubed plus y cubed. So the first sign is the same. So we have a plus there, so this is going to be x plus y. Very easy to remember. Then the next one, you have x squared. The sign that comes after that is different. This is plus, so this is going to be minus. Then it's xy, and then it's plus. This one's always plus, and then it's y squared. Okay, so very easy to remember. So kind of following this format, if I look at this, I have x cubed, and I have 125. So 125 is 5 cubed. So all I need to do is put what? It's going to be x plus 5. X is what's cubed here. 5 is what's cubed here. So we have x plus y here. X is what's cubed. Y is what's cubed. So we have x plus y. Here we have x plus 5. Then following this format, we have x squared. So we have x squared minus xy. In this case, we have x times 5. So 5x. And then plus, we have y squared here. So whatever is cubed, that's now going to be squared. So 5 is what's cubed. So that's going to be squared. 5 squared is 25. So we get the quantity x plus 5 times the quantity x squared minus 5x plus 25. All right, let's take a look at one final problem. So what is x cubed, again, minus y cubed? So again, the first sign is the same. So x minus y, same sign. Then the next one that we're going to think about after the x squared is different. So this is a minus, so now it's going to be a plus. And then we would have xy. And then this sign right here is always a plus. So we have plus, and then we have y squared. So following this format, we have a cubed. A is what's cubed. And we have 64. 64 is 4 cubed. So 4 is what's being cubed. So follow the format. So whatever's being cubed in the first position, in this case that's a, minus whatever's being cubed in the second position, in this case that's 4. Then times. Whatever's being cubed in the first position is now squared, so that's a squared. Then plus, we have whatever's cubed in the first position times whatever's cubed in the second position. So a times 4, or 4a. Then plus, whatever's cubed in the last position, in this case that's a 4, we're going to square it, just like it is here. So 4 squared is 16. Close the parentheses, and we have the quantity a minus 4 times the quantity a squared plus 4a plus 16. So just something to keep in mind. These formulas are going to greatly speed up your homework and your tests. So something you definitely want to memorize. What I always suggest for my tutoring students is write out the formula that you know, and then just make the comparisons like we're doing here. Okay, if I know x cubed minus y cubed is the quantity x minus y times the quantity x squared plus xy plus y squared, I can just represent everything and then go through and match up my formula and do it like that for a while. And, 20 or 25 problems later, you won't even need to write the formula down. You'll have this stuff memorized.